Hi, this is Tony Northrup for TrainSignal, and in this video lesson I'm going to cover the concepts of security administration for the SSCP certification exam. Up first, let's talk about data classification. This is basically figuring out which of your data is the most important, which needs to be restored first and backed up most often, which is super confidential and needs to be highly protected and encrypted, and which isn't that important and you shouldn't spend so much time and storage and money on keeping it safe. As I was saying, data classification determines your security restrictions and backup policies. If there's a particular file, maybe you can handle losing 12 hours of work that an employee was putting into it, or maybe it's something that you can't handle losing a single transaction. For example, if you think about, the New York Stock Exchange, whenever somebody makes a transaction, if they buy a stock or sell a stock, well, how long do you think they could stand to lose if a hard drive failed? Do you think they could stand to lose 12 hours of trading transactions? No, they couldn't stand to lose the records of a single transaction. So that data has to be backed up constantly. On the other hand, imagine that you have temporary workers just doing data entry, just entering in customer information from paper. Do you think you should pour tens of thousands of dollars into offsite data synchronization to make sure that not a single record is ever lost in the event of a natural disaster or hardware failure? Well, probably not, because if the server they were entering into failed, you would just say, come back tomorrow, enter in the same paperwork again, and it would cost you whatever their hourly wage was. And you probably wouldn't lose the hardware anyway. So that's something we're going to cover when we do risk assessment in more detail. But in the stage where you're classifying data, you'll just be deciding, this data doesn't cost me that much if I lose it. Or this data is so critical, I have to spend whatever I have to spend to make sure I don't lose a minute of it. It also separates the secret stuff from the public stuff, and the critical stuff from the disposable stuff. So their New York Stock Exchange transactions, for example, are generally considered top secret, and you wouldn't, for example, want it to be public that somebody was going to be selling a whole bunch of their stock, because other people could come in and abuse that, and that would be highly illegal. And it would also change the financials for the company. So that's highly confidential. However, when the office manager sends out the weekly notice saying what they're going to be selling for lunch every day in the cafeteria, well, you don't need to spend a bunch of money putting that onto hardware encrypted drives that cost thousands of dollars and putting it into a data center with an armed security guard. No, you shouldn't spend $1 trying to protect that. It doesn't matter if it leaks. So here are some different ways to classify data. The first are the time criteria, and this is pretty much stored in the file's metadata itself. You can just view file properties on just about any operating system, and it will tell you when it was created, when it was updated, and when it was accessed. And the way you can use this is, stuff that was recently accessed, recently updated, is probably more important than older stuff, right? If there's a file that hasn't been read in 5 years, well, maybe you don't need to back it up every 20 minutes. It might not be any less confidential, but it probably is less business critical. And if you're putting together a business continuance plan and you need to determine which files are the most critical to restore right away, well, time is one way to determine which files can wait a couple of days to restore. Because in a situation like that, you're limited by the bandwidth. You're going to be pulling out hard drives from an offsite disaster recovery center and unloading the most critical files that people need to access right away. And it's going to take some time for those files to be copied from the drives over to your temporary or production systems. So you're going to be moving the files that are most important first. And how recently accessed and updated files are is one of the ways you can determine which one should be moved first. You can also look at the metadata of a file, which will reveal who created it and the type of the file and where the file is stored. So database files, you might decide, are more important than regular text files. Log files, for example, might not be that critical. PowerPoint slides or Word documents, which might contain company secrets and strategies, however, might be more valuable to you. Additionally, files created by the CEO of the company might be more important than a file that was created by a receptionist. And the most difficult to assess is the content. And content in a file can be structured or unstructured. Well, it's almost always structured in some way, but when I say structured, I really mean files like XML files that can be parsed by a computer. If a file is structured in that way, then you can use automatic data classification criteria to help assess it and determine what it is. If a file is unstructured, well, you have to have a human being look at it and try to figure out what the content in it is and assign some sort of value to it. So the content criteria is fairly manual and difficult to assess. It can't be done automatically like the time or the metadata criteria. So here's some really common data classification uses. You determine how data is to be backed up and how frequently. You determine which data is restored first in a disaster or a business continuance scenario. You determine which data is to be indexed for search and how. So part of this is looking at the metadata, figuring out whether the file is structured or not, so you can determine whether it's even possible to index it and search it. And if it is it something that anybody would ever want to search, because there's some cost to searching. You have the additional storage cost because you have to index all of the words in it and possibly the phrases and store that somewhere. It also takes some time to actually process it, so there's some computing power that goes into it. And there are lots of files that you don't ever need to index. Log files, for example, typically aren't indexed. Therefore, you can use data classification to determine which files should and shouldn't be searched. You can use data classification to determine which files should be encrypted and with which algorithm. Now, in the private sector, if you work for a business, an enterprise, or even a non-profit organization that's not covered by regulatory requirements, well, you can probably just use whatever the default encryption system is in your file system, and that will be just fine. But if you work for a government organization, especially the military, they choose their cryptographic algorithms really carefully, and you have to use a specific algorithm with a specific key length, and anything else would be illegal, and it wouldn't meet your regulatory requirements, and there'd be a lot of trouble. So through data classification, you could determine which files need to be encrypted with which algorithms. But again, that really doesn't happen in the private sector too much. And again, in government and military, you can determine your mandatory access control levels, whether a particular document is top secret, secret, classified, unclassified. You can also determine how assets are disposed of, because most files aren't going to live forever. Nobody's going to care about it in 1,000 years. So you might decide, well, these files can be destroyed after 10 years. Often there's a specific lifetime assigned to it. Financial documents don't usually need to be stored forever. For example, most countries have a tax system that will only look back a certain number of years. So it can actually benefit you to get rid of stuff that's older than that. You're no longer legally required to have it, and it can only cause trouble sometimes. So sometimes organizations get rid of old financial records. In the government and military, many types of documents become declassified after a certain number of years. Usually it might be 30, 40 years, but a classified document will be released to the public for historical reasons. So by classifying these documents, you keep track of how old they are and when they can be basically disposed of. Here are some examples of data classification levels. You can see the different ways that data can be classified. You can determine who it's viewable by. So public documents could be viewed by everybody. Internal documents, you might say just select employees. And again, confidential, probably a smaller set of select employees. And secret would be, very high-level ranking people. There are different levels for data integrity here, which means whether you're calculating checksums and auditing who makes changes to every file. And some files you don't really care when people update them. You don't ever need to track it back. And other really important files, it's really critical that you know exactly who changed it and exactly what they changed. Impact of disclosure, of course, public documents, you don't mind if they're disclosed. Top secret documents, it would be a real problem. The impact of loss, whether or not a file is recoverable, and if a file isn't recoverable, just what it costs the organization. And for some documents, that can be catastrophic. You also have to consider the value to the competitor, which is just another way to measure the value to your own business, right? So if you come up with a trade secret, I don't know, the formula to Coca-Cola, if a competitor gets that, they could take your business away, and you might lose millions or billions of dollars. So clearly, that particular document, really, really valuable, and just another reason to classify it as being really important to protect. Here are some ways to classify data availability. The nice to have column here says that if the data isn't accessible for a week, that's okay. If a server is offline, well, they can just check on it tomorrow and be able to read it. And you see this example has different columns here. Mission critical says that only an hour of downtime would be acceptable. And usually an hour of downtime is okay. There are times when we can't access resources that we need. If it's a critical document that people use to track a really important project, well, if they can't get to it right away, maybe they go have lunch and come back and it'll be ready. The availability of mission critical documents is often measured in the number of nines. So if you look at the percent available there, you'll see it has 4 nines, 99.99%. Often you get into 5, 6, 7, 8 nines, and at this point you're talking about being not available for just a few minutes a year, and even that can be a problem. Nobody ever talks about 100% availability. I think we consider that ideal, but it's very rare. But after all, if you have a file stored on a server, at some point you're going to have to install an update on the server and reboot it, right? And while it's being rebooted, it's probably not available. You can develop clusters and different types of distribution, but 100% availability over any long period of time is pretty well unheard of. But we add more nines and reduce the amount of downtime as much as possible. Now let's talk about asset management. Asset management is keeping track of the stuff you want to protect. Your buildings, your hardware, your software, your data, your intellectual property. You probably don't even have a good idea of the assets in your own house, right? I know I don't. I have all these boxes in the basement, and I know some of them have stuff that's really important to me, but if I were to lose it, would I know where to go for it? No, I really don't, because I don't have a good asset management system. But for companies who might have millions of dollars put into individual assets, of course it's really important to track it. Different people categorize asset management differently, but here are 4 commonly used types of asset management. Physical asset management, things like buildings. Fixed assets management, this is a financial construct used by accountants. IT asset management, things like computers and networks. And digital asset management, these are digital files and photos and videos, whatever you have that you might need to protect. So the asset management process covers the entire process of owning anything. Whatever it is, here's the general steps that you go through. First, you design it, whatever product it is that you're going to be storing. And, if you think of a new office building, well, you'd design it, and it wouldn't necessarily mean that you'd be designing every single doorway in the building, but you'd be saying, well, we need offices for 10 people. Or if you're buying a new computer, the design process might be, well, I need 2 processors and 4 gigs of RAM. The construction is the purchasing process, whether you're building it yourself or you're hiring somebody or you're just buying it off the shelf. That's the construction process. And the commissioning process is really deployment in the IT world. It's getting it set up and running. Number 4 is operating, and this is simply the facility or asset in use on a day-to-day basis after it's been deployed. Number 5, maintaining, are tasks that you need to perform to keep it in running condition. So in a building, of course, you have to clean it. You probably have to have it inspected to make sure that the foundation isn't crumbling. On a computer, you need to install updates. Number 6 is reporting. So you're just checking out and making sure that you're meeting health code if you're a restaurant, or that a computer is up and running if you're in IT. Upgrading, of course, you make a decision that whatever it is no longer meeting your needs and you need to make a change to it. On a computer, you might be adding more RAM. For a building, you might be expanding the building or reorganizing the walls or adding additional resources to it. A new refrigerator in the kitchen, whatever it is. And finally, disposing. Nothing lasts forever. Your server gets old at some point and you need to know when it's time to throw it away and exactly how you need to do that. And part of the asset management process is evaluating the importance of your assets, determining the things that are most important to you and those that you don't care so much about. There are a couple of different ways to do that, and those are quantitative and qualitative. And you'll see this quantitative versus qualitative throughout these lessons because it comes up a lot in security, because a lot of security is determining what you need to put your time into. Quantitative is assigning a dollar value to an asset. It's determining what the company loses if the confidentiality, integrity, or availability of that asset are compromised. Qualitative is easier to assess. Quantitative actually requires math and numbers and facts. With qualitative, you kind of feel it out and you're like, this is really mission critical, or this is a lower priority. It's a subjective assessment. It is your feelings or your organization's collective feelings about a particular asset. Sometimes it's so obvious that qualitative is fine. And sometimes you have so many assets or people don't necessarily agree about the priority of something and you have to go to quantitative and assign an actual dollar value to it. Quantitative evaluation answers the question, what does it cost us if we lose this asset? Now let's talk about security control documentation. This is the documentation that defines the security settings in your organization, everything from the networking equipment to the firewall settings and the server and client host configuration security settings. I'm surprised how many organizations have nothing about this. I go into consult sometimes and I'll say, well, let me see your security control documentation so I have an idea of how you do things. And they'll be like, what? They just install servers and then they expect their IT administrators to just implement best practices as they see fit. Like, they just kind of trust them to know exactly what they're doing. And that sounds nice, except you have no baseline. If you don't think about it and define how things are going to be, then you don't know when they slip out of control. You have nothing to measure against. So it is really important to sit down and design your security controls. Your security control documentation defines your access control system by specifying who classifies data, every single firewall policy, what your file permissions are going to be, and for example, who can set file permissions. Is it defined by the owner, or is it defined by management or some third party? It defines your user management policies. For example, what happens when a user forgets their password, whether accounts are locked out after a certain number of incorrect attempts, what your password requirements are going to be. It defines your encryption requirements, which algorithms you use and which files are encrypted and who holds the keys to them and who has the emergency recovery key and how that's stored. It defines what users are allowed to do with computers, and we'll go into more detail about that later. And it defines your personnel policies too, because that's really where security starts, by hiring the right people and handling them. So at some point, somebody's going to do something that violates your security acts, and well, how do you handle it? You probably pull them aside and warn them, right? But you need to document that just to make sure that you follow the correct procedures. There are 3 different documentation types. Standards are a long list of the way you're supposed to do things. So you can say firewalls at every connection to the internet, and they deny all incoming requests by default, and they allow only ports 80 and port 443, HTTP and HTTPS through them. Those are examples of standards. They tend to be just a long list. Guidelines are a little more subjective. They're not quite so black and white. Guidelines are best practices and suggestions. Administrators should do this. And if, an administrator doesn't do it, well, you'll come back and you'll say, look, we have these guidelines. They're there for a reason. But they're not quite as strict or factual. And finally, procedures are step-by-step processes. So you'll have a procedure for how you handle a user who's forgotten their password. And of course, that procedure is going to involve authenticating them, making sure that they really are who they are without asking them their password because they've forgotten it, and how you communicate that password back to them. So you're going to have hundreds of these little procedures that you have to follow. Because imagine if you didn't have your password reset procedure documented and you just let whoever answered the phone figure out how to reset passwords. Well, that's how companies get hacked. Because the guy who answers the phone, he might be like, oh yeah, that sounds like Gary. I trust this guy. I hear the tone in his voice. Gary forgot his password. I'm going to get him a new password. You need to have a procedure for that, and you need to make sure people follow it. The famous acceptable use policy. This defines what people can do on their computers. And, as time has gone on, computers have gotten more and more abused. When I first started in IT in the early 90s, well, these computers weren't networked. You could run your word processor in DOS, and you had a printer plugged into your computer, and you basically used it like a typewriter. Maybe you had a spreadsheet, but in the end you ended up printing stuff out. And Windows came with Solitaire and Minesweeper, and somehow, even with the most boring computers you could possibly imagine in a modern era, people still managed to abuse them. Because you'd look over and you'd see somebody playing Solitaire, and you know what? I got really good at Minesweeper. So imagine how much computers get abused in the modern era when all these computers have internet access, and you can get a constant stream of what your ex-girlfriend from high school is doing on Facebook, or you can be playing Minecraft, which is way better than Minesweeper, and you can go to Reddit and see hilarious cats doing things 24/7 just as fast as you can click the next button on your computer. So nowadays we define very carefully what users can and can't do on their computer. So you probably define a policy that says you can use your computer to check your personal email, and if your wife sends you a message about daycare, go ahead and read it and reply back. But, please don't go to Facebook and just browse because you're bored. Please don't play Minecraft or a video game on it. Or maybe you're a progressive and liberal company and you just let employees do that. Whichever it is, it's important to document it, because at some point somebody's going to be breaking a rule and they're going to be irritating management by wasting all their time on Facebook, or they're going to perform some illegal act like hacking or using your network for piracy. And if you haven't written an acceptable use policy, you have a hard time defending a position and punishing that employee. So that's really what the acceptable use policy does. It allows you to bring down the hammer when somebody finally does something bad. It might seem obvious that you shouldn't use the corporate network to pirate things, and it's probably against your local laws. But it's hard to hold the employee accountable rather than the corporation if you don't have an acceptable use policy in place. So tell people what they can and can't do, and on that acceptable use policy list, all the stuff you don't want them to do and all the stuff that's illegal to do. I'm not going to go over acceptable use policies in detail, but if you search the internet, you can find predefined acceptable use policies that cover just about any style of management. The acceptable use policy should also define devices, whether employees are allowed to bring their smartphone in or their tablet in, and what they can do on those things. Because nowadays, you can block Reddit and Facebook at your firewall, and then employees will just pull out their phone and do it, and they'll use the wireless broadband connection that their phone has. So there's no real way to restrict employees from doing things with smartphones or tablets or their own devices, except searching them at the front. Now, that's pretty harsh, and people really do need their devices for their own personal reasons, because we still might need to be able to hear from our spouses or kids when we're at work. But you can put a policy in place that says don't be playing games on your phones and tablets. USB drives also need to be addressed because people use these to transfer confidential data outside of the confines of your network. Somebody can copy a file to a USB drive, and you can no longer audit it. You don't know where it's going to end up. They might drop it in the parking lot, or they might take care of it. You don't know. If you allow these, fine. Tell employees how to handle them. Tell them that they need to use, say BitLocker or another form of encryption on the USB drive. Tell them outright, even if you decide to allow it. And if you don't allow it, it's even more important to specify. Privacy is more important now than it ever has been, and people are really sensitive about how their data is handled. For example, if you work at a credit card company, well, you have a really detailed list of what a person does and likes. If they use their credit card, you probably know what restaurants they go to, what days of the week. If they go out of town, you know it. And not everybody wants that information to be public. In fact, most people don't. And I think most people understand the need for consumer privacy inherently. We just feel bad if somebody knows this kind of private stuff about us. I'll say that I, for a long time, didn't really understand it. I didn't see any need for anybody to protect the privacy of the things I was doing. I would happily let the whole world know that I eat at my favorite restaurant, Milagro, every Thursday night, and it wouldn't bother me. So I never cared if my privacy was really protected by a company. But for those of you who think like me and don't necessarily understand it, I'll give a couple of examples. One is that of theft and fraud. If somebody knows that I go to Milagro every Thursday night, well, they might think that's a good time to break into Tony's house, right? So by exposing your habits, you also make it easier for somebody to victimize you. If Facebook or a credit card transaction reveals that you're out of town, well, your house might not be occupied or monitored. It might also reveal private things. If your internet searches aren't held private and you're shopping for your wife's birthday present, well, she might hop on your computer and stumble across it and ruin the surprise. Now, we can all think of much more nefarious reasons that we want to protect our privacy, but there are legitimate reasons for consumers to want to protect their privacy, and it's really important to many people, so it's important that you enforce that too. And if you don't, people are going to call you out on it, and it's going to be really embarrassing for the company, and it could cost a lot. You need a privacy policy for your employees that tells them exactly what can and should not be shared outside the company. This is really critical in healthcare companies or anytime you're dealing with consumer records, because you're protecting the privacy of the consumers. And for healthcare companies, you have things like HIPAA regulations that define both what you can and can't share, and pretty stiff penalties for breaking those regulations. So if you break those policies, it could cost your company a lot of money, and it could cost you your job. Of course, the baseline for a privacy policy is to comply with applicable laws and regulations for your area and your business sector. You might even take it a step above that, but that's a bare minimum of what you need to do. The privacy policy dictates how your data is collected, stored, and transmitted. So part of collecting it is going to be gathering that data. Do you use HTTPS connections to encrypt it? How do you protect the data while it's being collected? If you think about it, if students in a high school class are filling out an evaluation form for their teacher, well, there's this really simple privacy policy. They always make them turn them upside down and then slide them into a box so it's kind of anonymous. That's a start, right? A step above that would be to have a third party come in and collect them so that the teacher never gets to touch it. So there are different levels that you can specify for how data is collected. Of course, data storage, you have things like caching and encryption and access control lists and mandatory access controls. All of this is part of your storage privacy policy. And finally, how private data is transmitted, and usually this means authenticating both the client and the server and then adding some sort of encryption. Depends on the sensitivity of the data, of course, because you're adding a lot of overhead, so you don't want to do this for all your data, but then again, maybe you do. Your data loss policy specifies what happens when data disappears, when you lose it, when you accidentally delete it, when there's a hardware failure and you can't get it anymore. It determines how you protect different types of data, as you'll determine during your data classification process. How you dispose of outdated data, as I was talking about. Some data just becomes outdated and you need to get rid of it. But do you just press delete on your keyboard and send it to the recycle bin? If it's physical data, do you just toss it in a bin, or do you need to shred it? Maybe you need to physically destroy the hard drive that it was on, or perhaps you use secure deletion techniques that overwrite the data on the now unused part of the disk to make sure that it can't be easily recovered with data forensics techniques. Basically, your data loss policy determines how you respond to confidentiality, availability, and integrity compromises. That's that CIA triad. Here's some other policies that you might want to create. Your mandatory vacation policy, which goes along with the security best practice of mandatory vacations that I covered in another lesson. The same applies for job rotation and separation of duties. Least privilege, of course, simply defining that nobody should have more rights than they absolutely need to do their job. The password policy, which will define your complexity and length requirements, as well as how frequently users have to change their password and how many passwords you remember to prevent them from changing it back to the old password. The clean desk policy, which sounds like it might be about hygiene or staying orderly, but it really is about security, because when people have messy desks, well, the stuff on their desk is often confidential stuff. Even a stack of paperwork probably has some confidential data in there. It also means that the data isn't well tracked or organized. So if the CEO has a stack of personnel reports to go through and they're just sitting on his desk in a big stack of paper, who's to know if a cleaning guy comes along and steals that? If stuff isn't locked away in a filing cabinet, who knows if somebody has access to that office and they just quickly take pictures of it. Keep your desk clean. Not only does it make you a more productive person, but it makes the whole organization more secure. The due care policy is a policy that basically protects you from being negligent in whatever task it is that you're trying to perform. So sometimes these are often defined by legal requirements or regulatory requirements, but they're also defined by liability concerns. You don't want somebody to sue you because you haven't taken due care and you haven't done your job properly. The document disposal and destruction policy, which we've talked about already, and the incident response policy, which defines what happens when bad stuff happens, how you respond when somebody breaks into your systems. And now let's talk about auditing, which is the process of verifying that implementation matches the design. Auditing should always be required and scheduled. Depending on the types of policies that you're auditing, you might have an audit going on every week, or it might be every 6 months, or it might even be just every couple of years. But it's important that you schedule it because nobody ever has time for an audit. If you say, well, we'll audit as soon as stuff slows down around here, well, it's never going to slow down. There's always going to be some new task on your plate, and then you'll never perform the audit. And then guess what? Your security is going to gradually degrade. Because if you don't audit, if you don't check up on things, stuff just falls out of place. It just happens over time. Somebody changes a setting because they're trying to fix something, and they never go back and fix it. It's happened to me many times. When host-based firewalls were first new, applications often didn't work properly because the firewall wasn't allowing the communications through. So as an IT guy, the first step that you always took was to temporarily turn the firewall off to see if the app still worked. Well, guess what? Once the app was working, people would forget about it. They'd be like, oh, turning the firewall off fixed it. My app works. Get out of here, IT guy. Well, that's not the proper way to do it. What you should do instead is realize that turning the firewall off means the firewall was the source of the problem, turn the firewall back on, and then configure it as needed. But that isn't how things went down, and you would never know it unless you audit. The firewall would just stay off. But as soon as you ran an audit to make sure that everybody was running host-based firewalls, you'd realize, oh, this guy over here doesn't have a host-based firewall. We need to figure that out. So that's what I mean when I say that without auditing, security degrades. Everybody needs to audit, but it's often legally required by regulations that might impact your particular type of business. Auditing requires separation of duty. And what I mean is you can't ask the IT guy who configures the firewall to also audit the firewall. Because if he's done something hacky, like opened up a port he wasn't supposed to just to make something work, he's just going to overlook it because he doesn't want to get himself in trouble. Another reason for separation of duty is that we all have different priorities and our minds all work in different ways. So the IT guy who sets up the firewall might not think that blocking HTTP is all that important. Or he might have completely forgotten about enabling a particular setting. He's going to forget about it during the process of auditing too, right? So you have a third party do your auditing, and sometimes that's somebody else within the organization, hopefully somebody not reporting to that person or somebody not close to them. The more detached, the better. Sometimes you even outsource it. You bring in an outside organization. That's really the best way to perform an audit because you can trust a third party who's being paid just to expose the things you're doing wrong. They're not going to pull any punches. And in fact, their reputation depends on finding the stuff you're doing wrong and being totally frank. So you really can trust that they'll do that properly. During the course of auditing, you'll find things that fail the audit, things that aren't implemented the way they were designed. And you should do what they call a post-mortem. You should take a look at what happened to make it fall into that degraded state and what you can change about your processes to prevent it from happening in the future. And please remember, nobody gets 100%. Everybody messes something up, and the audit is designed to find that. That's why we have auditing. If some people got everything perfect, we wouldn't necessarily need auditing. But we do. So when things pop up and you didn't do something right, it's okay. In fact, you get credit for it because now you really can be perfect. The process of auditing allows you to be perfect. But don't expect to get everything right in the first place, and don't have your feelings hurt. There are many different types of audits, and I'd like to go over a few of them. The first up, user rights and permission audits. This is basically auditing your access control lists as well as the user rights that you have assigned. You'll ask yourself, do users have the access and privileges that they need and no more? Who has administrative privileges, and is there any way we can pare that down a little bit and assign it to fewer people? You should work with your management to determine what the expected rights and permissions should be, but then again, hopefully you've documented it in your security control documentation. Administrative audits really audit the processes that you follow. Is everybody following change management? Is everybody creating the documentation that they need to create when they update settings or add new equipment? Escalation audits ask if everybody knows who to contact in an emergency. They verify that communication channels work in the event of a disaster or an attack that's underway. And they ask about events that have already occurred, whether the policies were followed. So you can look at particular break-ins, power outages, compromises, and say, did everybody respond the way that they should? And if they didn't, well, how can we get it right next time? Regulatory audits are only required if regulations apply to your particular organization. Things like HIPAA and SOX and PCI. If you're in one of these fields, well, hopefully you know it, and if you're not, then you don't have to ever worry about these. Each of these regulations mandates some sort of auditing, so check the regulations to make sure that you're following their requirements for auditing and reporting. And here's what audits typically find in my experience. They find misconfigurations caused by updates. In other words, you can apply an update in good faith and think that you're making the world a better place and that you're making the system more secure, but that update might actually change a setting for the worst, and an audit will find that. It also finds oversights. People were supposed to set this and this up, and they simply forgot. Happens, we're human. It finds quick fixes, like I described, where the administrator turned off the guy's firewall to fix a problem and then forgot to turn it back on. Audits find failures to implement a design. So sometimes you go through the trouble of designing something and then you find out that the person who installed the software just used all the default settings. Audit will find that for you. It also finds external security compromises. So often what happens with a security compromise is somebody will install a new piece of software like a bot, or they'll open up a back door to themselves, maybe by changing the ports allowed on a firewall. You'll do an audit and you'll say, well, why the heck is it allowing incoming connections on port 666? And then you'll look up that port and realize it's used by some piece of malware, and it indicates that somebody's broken into your system and they wanted to be able to control the system in the future, and so they opened up a new port. That's one of the exciting things that you find in an audit. It also finds internal compromises such as fraud. You might find that an ex-employee installed some software that allows them to continue to access the network. In a financial audit, you might even find that accountants are stealing from your company, committing some sort of fraud. This is Tony Northrup for Train Signal, and thanks so much for watching this video lesson.